reaction, we have a table. In double displacement reaction or method-cis reaction, what is happening is like you have two solutions, the reaction takes place in aqueous solution. You have two solutions that they are aqueous solution, you are mixing together, and if you see evidence for reaction, you say reaction takes place, the reaction is happening. If there is no evidence for reaction, there would be no reaction. What is evidence for reaction? If solid forms, a precipitate forms, then there is a evidence for reaction. If gas forms, that's evidence for reaction. If a liquid forms, that's evidence for reaction. If color changes, you see an obvious color change, then you have evidence for reaction. So basically, in this case, for this experiment, when we are going to take our test tube A or test tube 1. These are 1 to 12, okay? We have 12 test tubes. In test tube 1, we are going to add solution of barium chloride and solution of sodium sulfate. These two are in solution form because both of them are soluble. If they go through method-cis reaction, then there would be exchanging partner is going to be barium going with sulfate. The cation from the first one goes with anion with the second one. So it's going to be barium sulfate and sodium chloride. So it's going to form barium sulfate with sodium chloride. Now, if either barium sulfate or sodium chloride is insoluble in aqueous in water, you are going to see formation of precipitate in the aqueous solution. So if one of the product forms a precipitate, then you know that is not, that's the evidence for reaction. You know one of your product is not soluble. You can actually predict based on solubility chart if the precipitate is going to form or not. And you can identify what is the precipitate that is forming. Because when you look at the sulfates in this chart, and your professor is going to explain the chart again. So sulfates are all soluble. On the next line, you have exceptions. So sulfates are soluble with exceptions to calcium sulfate, barium sulfate, silver sulfate. So this means barium sulfate is not soluble. So for test tube A, if you see a reaction, that reaction, the precipitate forms, is not the precipitate of NaCl, is not sodium chloride that is forming, because sodium chloride, if it forms, is soluble in water, but it's going to be the precipitate of the barium sulfate that is forming. So you are going to use your solubility chart. Whenever you have a precipitate, you are going to use your solubility chart to identify what was the precipitate, because this chart is saying what combinations is going to be soluble. Like if your compound contains group 1A, it would always be soluble. It doesn't matter if it's sodium chloride, if it's sodium bromide, or sodium acetate, or sodium sulfate. Whatever it is that has sodium is going to be soluble. If it has nitrate, it's going to be soluble. If it has acetate, it's going to be soluble, or ammonium ion is going to be soluble, with no exceptions. And everything else, there are some exceptions that you have to look at the chart and identify your precipitate. What is the precipitate? If you mix two clear solutions, you end up with clear solution. That means no reaction happens, no precipitate happens, because there was no benefit for that reaction, and your product is soluble in water. Okay, I'm going to start with the test tube. I'm going to label the test tube 1 to 12. And I'm not writing these formulas on the test tubes, what they are, because I have the table to follow. I know for test tube 1, I'm going to add barium chloride and sodium sulfate. So I'm going to take my test tube 1 and add the barium chloride and sodium sulfate. Test tube 1, barium chloride, sodium sulfate. They have it all in one place, so I'm going to be looking for them to find it, but So I'm adding 5 drops of barium chloride, and then I add sodium sulfate. Sodium sulfate. This is for my test tube 1. Barium chloride, I'm adding sodium sulfate. Adding 3 drops of sodium sulfate. Okay. The product is milky. That means there was one product that was not soluble in water. If everything is soluble, we would see clear solution just like water. So if it's precipitate forming, we identify the precipitate using the solubility table. But since I already looked up this one, is the barium sulfate. So that's our test tube 1. Test tube 2, we have silver nitrate and sodium chloride. Silver nitrate, all nitrates are soluble. So you see the silver nitrate is a clear solution. Sodium chloride also is a clear solution. When I'm adding the two, a precipitate forms. That precipitate is not sodium nitrate because we know any compound that contains sodium is soluble. Any compound contains nitrate is soluble. So it's not sodium nitrate, it's going to be the silver chloride because they switch partner. Sodium chloride, silver nitrate. Now sodium goes with nitrate and silver goes with chloride. So this is the silver chloride. So you identify your test tube 3. We have lead nitrate and potassium iodide. Lead nitrate, going to add a few drops of lead nitrate and add lead nitrate, clear solution again. Potassium iodide, Ki, clear solution. And then it's forming a yellow color precipitate. So you record your observation when you are mixing the solution of lead nitrate with potassium iodide. What happens when you add the two together? Is there any evidence for reaction? Yes, it's color change and it's cloudy, so definitely there is a reaction there. Test tube 4, we have barium chloride and sodium carbonate. Barium chloride, have sodium carbonate, clear solution. Yeah. Okay, barium chloride. And barium chloride, we used it earlier. We got barium carbonate. Okay. So test tube 4, also precipitate. So we have a precipitate. And that should be barium carbonate because we mix the barium chloride with sodium carbonate. When the switching partner, sodium would go to chloride and barium would go with carbonate. Test tube 5, sodium hydroxide and ammonium chloride. So in test tube 5, sodium hydroxide clear solution, sodium hydroxide being added, that's sodium hydroxide. And then I have another clear solution of ammonium chloride. Anything that has ammonium is soluble, of course. I mix it together and I get clear solution. What does it mean? It means that this mixture did not form any precipitate. There is no evidence for reaction. So for 5, there would be no reaction. So 5, no reaction. Test tube 6, lead nitrate with sodium sulfate. Lead nitrate, Sodium sulfate with lead nitrate. Gonna add few drops. Test tube number 6. White precipitate. That's going to be lead sulfate. Remember, partners are changing. Sodium was with sulfate, lead was with nitrate. Now lead goes with sulfate, lead sulfate. Test tube 7. Hydrochloric acid and sodium sulfide. Na2S. Test tube 7. No reaction either. So mark no reaction for 7. Test tube 8. We have copper sulfate and sodium hydroxide. Sodium hydroxide and copper sulfate. The blue color stays, but the blue color that we have for copper sulfate is clear blue color, but this one is cloudy, so there is a reaction. Okay. Blue color precipitate that changed the solution to cloudy mixture of solid and liquid. So test tube 8, yes, reaction, and you have blue color precipitate. Test tube 9, we have lead nitrate and potassium chromate. We have lead nitrate. See, it's clear, colorless solution of lead nitrate. Potassium chromate is clear, but yellow color solution. There is no precipitate in there. There is no solid. Both of them are aqueous solution. One had just happened to be yellow color, but it's clear. When you mix it, you get this yellow color precipitate. So for test tube 9, evidence is yellow color precipitate that it forms. There is a reaction, and the precipitate that forms, the insoluble compound that forms, if you do like double displacement, see, you are going to take the lead with chromate. So lead goes with chromate, potassium goes with nitrate. Potassium nitrate stays in the solution. Lead chromate is going to be the solid that is forming. Test tube 10, iron nitrate and sodium hydroxide. Okay. Iron nitrate is a yellow color but clear solution. Okay. Clear solution. And we want to add sodium hydroxide. We have it somewhere. Sodium hydroxide. Okay. It turned cloudy. So orange color precipitate form is an orange cloudy solution mixture. So orange precipitate form. So for test tube 10, you do have a chemical reaction also because of precipitate form. and it's cloudy. 11, silver nitrate and sodium hydroxide. 11, we have silver nitrate, adding few drops of silver nitrate. And we add sodium hydroxide, silver nitrate with sodium hydroxide. See all different colors of precipitate. It's like a brownish color precipitate we have. Silver hydroxide. This precipitate is called silver hydroxide. Next, or last one, 12, sodium chloride and calcium nitrate. Sodium chloride, obviously, clear color solution, and calcium nitrate. Calcium nitrate. Sodium chloride with calcium nitrate. Okay, if you switch these, it gives you calcium chloride and sodium nitrate. Sodium nitrate is soluble. Calcium chloride also is soluble based on the solubility table. Because all chlorides are soluble, it's expressed in the solubility table. All chlorides are soluble with exceptions to silver, lead, and mercury. So calcium chloride is soluble and sodium nitrate is soluble. That's why you get clear solution. No reaction. So for test tube number 12, there is no precipitate, no reaction for test tube number 12. So the test tube number 12, there is no reaction. No reaction for 12. So we're done with double displacement reaction, single displacement reaction. You're not done with your experiment yet, because in this part, number 5 here, is asking you to write the chemical reaction. You just have to add the two reactants from test tube 1, compound A plus B, switch it, and make sure that you have the product in a way that they have switched or exchanged partners. The metal cation from the first one goes with the anion from second one, and then cation from second one goes with the anion with the first one. You write your chemical reactions. And then any reaction that doesn't have evidence for reaction, you can write no reaction, or you could write it down and then say no reaction. So you're just going to follow the procedure. For the part 6, you're going to write ionic equation. When you're writing ionic equation, anything that breaks down to ions, that means the compounds that are not soluble, they are going to stay in the solid form. But if they are soluble, they can break down to the ions. Let's say when you mix the first one, for the first table, when you mix the test tube 1, you mix the barium chloride and sodium sulfate. Barium sulfate forms the solid and is going to stay at BaSO4, and you don't separate them. It doesn't change to ions. But the second compound, which is the sodium chloride, it changes to ions of sodium ion and chloride ion. So when you're writing net ionic equation for question 6 or part 6 of the data sheet, you only change the compounds that are aqueous into ions. If they are solid, it stays. If it's liquid, it stays. If it's gas, it stays. But for this example, you either have aqueous or solid. You don't have the gas liquid as example. So it makes it more straightforward for precipitation reactions. So if it's solid compound, it stays together. Do not break it down. And then if it's aqueous, you change to the ions. For part 7, when you have your ionic equation, you are going to cross down the spectator ions. Spectator ions, those are the ions that they appear exactly the same on both sides of the equation. So if you have an Na plus on the reactant side, you have Na plus on the product side, that is called spectator ion. You are going to cross it. Then you end up with whatever is left as the net ionic equation. Net ionic equation is responsible for evidence for reaction. So for the example with the barium chloride and sodium sulfate, the product that is barium sulfate, you're going to end up with net ionic equation. If you do every step correctly, your net ionic equation is going to be Ba2 plus, which is the barium ion, plus the sulfate ion that gives or yields barium sulfate solid. So that would be your net ionic equation. So for any reaction or any test tube that you did have a reaction, you should have a net ionic equation. If you have no reaction, like test tube 12, you had no reaction, everything is going to cancel from both sides of the equation. The spectator ions, when they cancel, you end up with 0 net ionic equation. So that means there is no reaction also. It's a proof that there is no reaction. Okay, we are done with experiment 7. Hopefully you can record all your observation and complete the data sheet for experiment 7 and turn it in as an assignment to your professor if it's me or anyone.